All right, so in our last explainer, we dug into all the brilliant ideas coming out of university labs. But today we are scaling way up. We're going to look at how entire nations are tackling the nuclear waste challenge. We're talking massive, government-led programs, billion-dollar facilities, and strategies that are literally designed to last for millennia. Let's dive in.
So, this is it. This is the monumental question at the heart of everything. I mean, how do you even begin to secure something for 100,000 years? That's a timescale that's almost impossible for us to wrap our heads around. And it's a central problem that every single national program we're about to see is trying to solve. How do you build something that can outlast entire civilizations?
Okay, our first stop on this global tour is the United States. Here, the Department of Energy is running one of the world's largest waste management programs, and their whole strategy, it's all built on one core idea: permanent, deep, underground isolation. The entire American approach really hinges on geology. The idea is to find rock formations that have been stable for millions of years. Think about that, and place the waste deep inside. You're basically letting nature do most of the work, containing it safely, far, far away from the surface and any possible human contact. And if you want to see this concept in action, look no further than the Waste Isolation Pilot Plant, or WIPP, down in New Mexico. It's a fascinating place. It stores waste from the nation's defense programs deep inside these ancient salt beds. And here's the amazing part. These salt beds are what geologists call plastic. Over time, the immense pressure from the rock above causes the salt to slowly flow and creep, naturally sealing the waste-filled caverns forever. It's incredible.
Now, let's hop across the Atlantic over to Finland. Why? Because while a lot of countries are still in the planning phase, Finland went ahead and actually built it. Their Onkalo facility is the world's very first operational deep geological repository. And you know what? It's setting the global benchmark for safety and engineering.
The Finnish approach is called the KBS-3 system, and it is both super robust and, elegantly simple. So, first, they seal the spent fuel inside these incredibly thick, durable copper canisters. Then, those canisters get wrapped in a special material called bentonite clay, which, get this, swells up when it gets wet, creating a perfect, impermeable barrier. Finally, this whole package is buried deep, deep within the bedrock.
And when we say deep, we mean it. The waste at Onkalo is buried more than 400 meters underground. To put that in perspective, that's deeper than the Empire State Building is tall. That incredible depth provides the final layer of protection, making sure that waste stays isolated for thousands upon thousands of years. Now, right next door in Sweden, they took a really interesting path. They used similar technology to Finland, but they decided to focus on a totally different challenge: the social one. They set out to prove that getting public trust is every bit as critical as getting the engineering perfect.
And what's so fascinating here is the contrast. You could say Finland created the technical blueprint. They proved the science and engineering could work. But Sweden, they created the social blueprint. After decades of total transparency and open communication, they actually had two different towns competing to host the final repository. That's a huge lesson. Technology alone is not the whole solution.
Okay, let's shift gears completely and look at a different philosophy altogether. Because in France, they look at spent nuclear fuel not just as waste, but as a really valuable resource. Their whole national strategy is built around recycling.
At their massive La Hague facility, they do something pretty remarkable. They take the used fuel, they chemically separate out the stuff that's still usable, that's the uranium and plutonium, and then they refabricate it into something called MOX fuel, that's mixed oxide fuel, and that new fuel can then be used to power their reactors all over again. And the impact of the strategy is just staggering. By recycling, France shrinks the volume of its most dangerous long-lived waste by 96%. That leaves only this tiny 4% fraction that needs to be put into permanent storage. It makes the final disposal problem dramatically smaller and so much more manageable.
Of course, the US, Finland, Sweden, and France, they aren't the only ones making big moves. There is important work happening all over the globe, with each country bringing its own unique innovations to this shared challenge.
So, for example, you've got Japan, which is meticulously planning its own long-term repository. In Canada, they're pioneering a new social model, working as equal partners with Indigenous communities to make sure these decisions are fair and inclusive. And just everywhere, we're seeing these incredible advances in robotics and AI that are making every single step of this process safer and more efficient.
So, here's the big takeaway from all this. These massive national programs are absolutely the essential backbone for nuclear safety worldwide. They build the foundation. But a new force is entering the game, one that can move faster and think a little differently.
That's right. Next time, we're shifting our focus away from these public, government-led strategies and diving into the super dynamic, fast-moving world of private industry. This is where a new generation of innovators is attacking the problem from totally new angles. We're going to explore companies that are developing advanced reactors designed to literally run on what we currently call waste. We'll look at new recycling systems that are more efficient than ever, and see how AI and robotics are making storage even safer. It's a peek into a future that might just redefine what nuclear waste even is. You are not going to want to miss it.
Welcome to our exploration of common myths surrounding nuclear energy. Many people believe nuclear waste remains dangerously hot and unusable forever, but science tells a different story. Today, we will debunk two major misconceptions about spent fuel and its long-term impact on our environment and energy future. True or false? Nuclear waste heats up storage containers indefinitely. The answer is false. While spent fuel is initially hot, its thermal energy decays rapidly within the first few years. In fact, after just 10 years, the heat output has already decreased by over 90%. True or false? 94% of spent fuel can be reused as new fuel. This is true. Through a process called reprocessing, we can extract valuable materials like uranium and plutonium. In the end, only about 5% of the original material becomes actual waste to be stored. Understanding the reality of nuclear waste is crucial for our energy future. By recognizing that heat decays quickly and that most fuel is recyclable, we can better appreciate nuclear power as a sustainable, low-carbon option. Let us continue to base our energy decisions on scientific facts. Knowledge is power. Please subscribe, like, and share to Think Tank 2.0. Thanks.